master mechanic and his principal assistants, working to precise production schedules, solve the many problems involved with repairing equipment to rigid technical standards, yet with maximum economy. As much prefabrication is accomplished off the ship as possible. Here, in our sub-assembly shed, the entire upper structure was constructed to replace the outdated one removed from a destroyer undergoing overhaul under the Fleet Rehabilitation and Modernization Program. Since most of the connections and joints, as well as ventilation and piping, are in the ceiling or overhead of the structure, it was constructed upside down initially so that work could proceed faster and more economically. It was then turned over right side up and completed. When the 35-ton unit was as complete as possible, it was taken to the ship by barge and very carefully put in place and secured to the main deck. In the same way, the ship's mast is constructed in the shop, completely wired and carried to the ship by mobile cranes. It is then erected and secured aboard ship. During the very critical center portion of the overhaul, much of the work is done inside the productive shops. Here, in our inside machine shop, for example, pumps, turbines, periscope, shafting, and propellers, and an almost infinite variety of other equipment is received for overhaul and repair. Each piece of equipment must be disassembled, repair parts ordered, indicated work accomplished, and reassembled. All rotating equipment must be balanced in order to keep vibration at a minimum and reduce wear. The balancing procedure is comparable to balancing the wheels on your car, but in larger scale. This large propeller, for example, is 21 feet in diameter and weighs 31 tons. Machining jobs are often complex or unusual, as on this radio telescope reflector for the space program. It is not always possible to procure replacement parts or sometimes whole new components from either commercial or Navy sources, and therefore local manufacture is necessary. We can demonstrate this with the evolutionary steps in the manufacture of a large anchor for a warship in our modern and completely equipped foundry. The sequence starts with making a mold from a pattern. Molten steel of the correct specifications is prepared in electric furnaces and poured into the mold. Excess metal is burned off. The anchor is heat treated to improve its strength. It is dressed by chipping, sandblasted, inspected, and finally delivered. We not only work with heavy metals, but also with light ones. Here in our sheet metal shop, much of the prefabrication is done for ventilation ducting, light bulkheads, special cabinets and shelving for storerooms, and ammunition spaces, as well as a very few items of custom furniture. Our electric shop and its supporting facilities can overhaul or rewind motors and generators of any size, switchboards, and all other types of electrical equipment, including submarine batteries and control cubicles. The electronic shop is also equipped to overhaul and repair the most complicated types of modern radar, radio, computers, and other electronics equipment. As the inside shop work is completed, material such as this destroyer smokestack is returned to the waterfront. Meanwhile, on the ship, in-place repair work has been progressing and must be complete so that material being returned from the shops can be installed in an orderly manner. Delivery of this material to dockside is phased and scheduled to be available when it is required by the shipboard forces. This reinstallation phase of the overhaul is a crescendo of activity involving all waterfront trades, and slowly at first, but then more rapidly, the ship begins to take on its ultimate appearance. Here we see a completely overhauled and reassembled main engine for a submarine being rigged and reinstalled into the main engine room. Because of the compactness of the shipboard spaces, The installation of these components must be done in a specific sequence, the reverse of the remove. This re-emphasizes the importance of scheduling and adherence to schedules. Here we see the plastic enclosure or sail of a submarine being reinstalled to give the ship its fair outer appearance. We saw earlier this catapult steam receiver from a carrier being removed, and we show it here being returned to the ship after its weld defects have been corrected, and it has been magnaflux, x-rayed, sandblasted, hydrostatically tested for strength, and repainted. This represents 4 months' work on 14 such cylinders. New or repaired radar antennas and other such components must be reinstalled in time to permit hookup, so that the work on associated system components can be proven.